Hello all. So in the last session we were discussing about machine translation theory. So today in this session I would like to discuss about how do we build a machine language translator. Okay. So we will proceed with the session. So we will start with how do we build a machine language translator. So similar to how did we build our machine learning and deep learning models, we also use the same steps with some difference for building a machine translator. So here is the simplified process of building a machine language translator. First we start with data collection, and then we do the text pre-processing of the data that we've collected, and then we'll go for feature extraction. We build the model, train the model, evaluate, and then finally go for inference. Okay. So when we talk about data collection, you can choose either of the methods. One thing, you can obtain the data from the large corpus, or to begin with you can create your own data set with small sentences for conversion. Okay. So for both the procedures, you're supposed to take the source language and the target language. The source language will be the input language that you want to take, and the target language would be the output language that you want to convert to. Okay, so you can either take corpus or create your own text. Okay, now this corpus that we take will be used to train the translation model. Okay, so the accuracy of the model will depend upon how much training data are you giving to the model. Okay, after we collect the data, we try to clean the text data by removing special characters, stop words, numbers, or any other unwanted symbols. Okay, so this is one part of pre-processing, and after we do that cleaning, we go for tokenizing the text, because as discussed in NLP, the data input would be text and that should be converted into tokens, right? The word to vectors. Okay, for vocabulary mappings we do that, and then after that we go for feature extraction, that is convert the text data into some numerical format that the model can understand. This typically involves various techniques, like you can go for word embeddings, you can either use word to vector or globe, etc. Okay, so after we do these three basic steps, we go for model architecture. We will choose a suitable architecture for your translation model. So one basic common approach is used to use a sequence to sequence model. Okay, so as discussed in the first session, we go for encoder decoder model architecture. Okay, so wherein we take the encoder to process the input, and then the encoder block will take the input, process that, and generate one fixed size representation word vector, and then this fixed size word representation is decoded by the decoder into the target language. Okay, so these are the first four steps. After that, after we build the model, we go for training the model. Okay, so we train the model on the parallel corpus using suitable optimization algorithm. You can go for your own choice. Okay, so during training, the model will learn to minimize the difference between the predicted translation and the actual translations. Okay, so after you train the model, we'll go for evaluation. That is, we'll evaluate the performance of the model using a separate validation set. Okay, so for machine translation, we can use two different common metrics. One is BU, bilingual evaluation of understudy, and the second one is translation edit rate. You can use either of them. In the example that I'm going to explain today, I have used BU. Okay, now once we are done with evaluation, once the model is trained and evaluated, we can use this particular model to translate. We can give new input text from the source language and try to generate the target language. Okay, so during inference, the input is passed to the encoder, and the decoder will generate the target output language. Okay, so when I talk about these 7 steps, we will have a small corpus. Okay, so let's take English to French conversion. I have taken English to French conversion. You can opt any two languages. One would be source and one would be the target language. Okay, so when I talk about pre-processing, as I am creating my data, I will not give any unwanted data, that is stop words or all that stuff. So I'll skip that step for now. I'll directly go for tokenizing the sentences and create vocabulary mappings. Once I'm done with that, I'll be using the pre-trained word embeddings for simplicity, that is feature extraction. After that, we will be using basic sequence to sequence model with LSTM cells. You can either use GRU or RNN also. Okay, and then we will try to train the model on our parallel corpus. We will evaluate using BLEU score, that as I told you, I am using BLEU score here for evaluation metric. And then finally, once I'm evaluating the code, I'll go for implementing a function that will translate new input sentences and perform machine translation. Okay, now let's go back to the code. Okay, now I'll explain you the code step by step. So here I've imported the basic libraries required. Okay, so I'm not going much into the importing library past. Okay, so you must be knowing what libraries we import basically. Okay, the first library that I have chosen is NumPy, which is the mandate library that we use for uh, any of the machine learning algorithms. Okay, now after that we have used TensorFlow because I am developing an RNN model. The neural networks are available in TensorFlow.keras. Okay, so from TensorFlow.keras I'm importing input, LSTM, embedding and dense, and then from TensorFlow.keras.models I'm importing model. Okay, so first I'll prepare my data. Okay, so for preparing my data, I'll create a small data set of English sentences. Okay, so I have taken 4 English sentences here. I'll create this small data set of English sentences and their corresponding French translations. As you can see, my input is English and output is my French. So input text are 4 sentences of English and the output is nothing but the target text, which is nothing but the French translation. Okay, so once I am done with creating the sample data set, next I'll go for data pre-processing, wherein I'll perform my tokenization. Okay, now as you can see here, we tokenize the characters in the input and target text. Okay, so input characters and target characters are generated from input and target text. Okay, now this is how I create vocabulary sets for both languages. Okay, so input characters and target characters are nothing but the characters that I'm generating from the given data. Okay, now after I do tokenization, I'll create token indexes because there are number of tokens which are generated. I want to create indexes for each character in the vocabulary. Okay, so for that I'm taking these two variables, input token index and target token index. Okay, now once I am done with this, I'll reverse the token indexes to map from index to character. Okay, just for mapping indexes to character, I'll perform reversing operation. Okay, once I am done with that, I'll determine the number of unit tokens. Okay, I want to identify unique tokens. Okay, so for that I will go for num encoder. Okay, so num encoder tokens, I'll identify number of tokens in each vocabulary. After that, I'll determine the maximum sequence length. Okay, maximum sequence length for the input text and target text. Okay, so after I do this, okay, this is what I am doing, and then I'll go for padding with zeros and all that stuff. Okay, now the reason why we create zeros, okay, creating arrays of zeros is used to represent the input and target sequences. Okay, to create arrays of zeros, we create arrays of zeros to input to represent input and target sequences. Okay, so for each sentence, please look at this, for each sentence in the data set, we encode the characters into one hot vectors, and after we do that, we store them. Okay, we store them in the corresponding arrays. For that I am using this. Okay, so once I am done with that, I use the input sequence for the encoder in the English sentence. I am using encoder for the input sequence indexing. I am extracting that, and then and the input sequence for the decoder, it would be the target token. Okay, so encoder is the English sentence and the input sequence for the decoder is the French sentence shifted by one time step. Okay, so that is what I am doing it here. Okay, once I am done with this, I'll define the model. We'll go for model definition. Okay, so we will define the encoder with an LSTM layer that processes the input sequence and returns the encoder states. Okay, so here I'm returning the encoder states, that is encoder underscore inputs, state underscore h, and then I'm also giving state underscore c. Okay, these are the 3 states. Now I will define the decoder. First I'll define the encoder Now I'll define the decoder. Okay, I do the same thing again. Define the decoder with LSTM layer that will process the target sequence and then uses the encoder layer as the initial states. Okay. Now, after I define both encoder and decoder, I will then use a dense layer with softmax activation function. You can use any activation functions. I am here using softmax activation function, and then you use your optimizers to predict the target tokens. Okay. Basically, define the model with the inputs and outputs. Okay, once you are done with that, we will compile the model. Okay, I'll compile the model with Adam optimizer here. As you can see, the optimizer that we are choosing here is Adam, and the categorical cross entropy loss is what I am choosing. I'll fit the model, train the model on the input and target data with validation split of 20%. As you can see here, I've taken the validation split as 0.2, that is 20%, and the batch size is 1 for 50 epochs. Okay, so batch size, once I am processing it for 50 epochs. So once I am done with compiling and training the model, I'll go for inference. So here when you look at the inference, what did I do here? I have just taken the encoder model, that is, I have defined an encoder model that will take the input sentence and returns the decoder states. It will take the input sentence, that is encoder, and it will derive the encoder states. Okay. Now, again I'll define the decoder model that will take this target, okay, this target sequence and the encoder states, and then it will return the predicted output. Okay, so the predicted output tokens would be nothing but the decoder states and decoder outputs. After doing this, I will define another function to encode the input sequence and decode the output, encode the uh, input sequence and decode the output sequence. Okay, so for doing the translation part at the end, okay, I am defining a function called encode input sequence and decode output sequence. Okay, so after doing this for translation, what I do is I'll get an input sentence from the user. Okay, I'll ask the user to enter the English sentence that he want to convert. After doing that, I'll encode that input sentence into one hot vector, and then I'll use the decoder output sequences model to decode the output sequences with respect to this particular data. Don't take input sentence here. We will take the one hot vector encoding representation of the input sequence, that is input underscore seq, that in the decoder, and then I'll try to print the translated sequence. Okay, so this is how we try to build a language translator. Okay, so we will run all the epochs and it'll ask us the input sentence, enter your input sentence, and it'll run for one epoch, one batch size for 50 epochs, and try to give you the output. Okay, so don't bother about the output conversion here. The accuracy is very low because we did not use blue score method here. It's a simple translator that I tried to explain. Okay, so the reason for not so good accuracy from English to French translation is because I have taken a very small corpus. Okay, so when you are implementing the model, I want all of you to take a big corpus. Only for explanation about how do we build a model, the basic language translator, I have taken a small corpus with only 4 sentences here. I want all of you to work on taking a huge corpus and try to build the model. Okay, so this is how we build the language translator. Okay, I'll repeat the steps once again. Import the libraries, create your sample data set, not with 4 sentences, but probably try to include more sentences. Okay, perform tokenization. Okay, convert the word vectors, remove the stop words if there are there, and then pad it with zeros to make the sentences unique. Define the model. Here I'm taking the LSTM model. Okay, compile and train the model, do the inference, and then try to translate your input sequences to output sequences. Okay, so this is all about language translator. Thank you so much.